So hi everybody, welcome to our webinar. Thanks for joining us this afternoon. This is our wrap-up webinar for the project called Deep Discoveries, and we're very happy to have you here where we would like to share our findings, our research and our methods. My name is Laura Angelova. I am the head of conservation research at the National Archives. I'm the PI on the project, but today you'll be hearing 3 talks from the people who did all the work on the project. On computer vision, on our interface development, and on the user research that we carried out. We had originally intended to have a webinar followed by a workshop, but as it's the height of summer and restrictions have been brought down, we've decided to cut the workshop part out. So we're just going to have a few talks today and hopefully a nice discussion at the end, so question and answer. So just as some background, Deep Discoveries is one of 8 foundation projects in the Towards a National Collection program, which is looking into the first steps necessary to create a unified virtual national collection. The program is a major 5-year investment of close to £19 million in the UK's world-renowned museums, archives, libraries, and galleries by UKRI, and it's being delivered by the Arts and Humanities Research Council, aka the AHRC. So the research carried out through the Towards a National Collection program aims to dissolve barriers between different collections, opening them up to new cross-disciplinary and cross-collection lines of research, and to extend researcher and public access beyond the physical boundaries of the collection's location. The projects are all exploring different methods, frameworks, and practices, things like citizen research, persistent identifiers, the implementation of IIIF, and other key topics that are relevant for addressing the program's aims. There are 8 foundation projects within the program, and they all kicked off right before the start of the pandemic. And in this autumn, we will see the starting of 5 larger discovery level projects, and there are also several other COVID-19 emergency projects. So Deep Discoveries, which is the project you'll hear about today, was looking into the application of computer vision search tools for enhancing the ability of general audiences and specialist researchers to discover visual collections in new or more effective ways. The project has 3 core participants: the National Archives, the University of Surrey, and the Victoria and Albert Museum. We have several project partners, including the Royal Botanic Gardens, Edinburgh, the Gainsborough Weaving Studio, the Museum of Domestic Design and Architecture, and the Sanderson Design Archive. We have a user experience research team that was assembled between the National Archives and the V&A, which also included a software developer from whom you'll hear today. And over the past 6 months, we have also been joined by a team from the University of Northumbria School of Design who were instrumental in the interface design. So the project has 2 primary work streams: a technology-driven strand, which was led by our first speaker, Dr. Dipu Manandhar, and Professor John Colomos, who worked on the development of computer vision search algorithms and their application for looking at more effective or interesting ways of cross-collection searching of digitized visual content. The second strand revolved more around user assessment and impact of the technology, and this was led by the National Archives, the V&A, and Northumbria, and involved the assessment of visual search users and their habits and needs in order to inform the design of a prototype search tool using the developed technology, which you'll get to see today in a demo. So today you'll hear talks from, as I mentioned, the University of Surrey team, represented here by Dipu, as well as John that I mentioned earlier. You'll also hear from Professor Joe Briggs from Northumbria University and Bernard Ogden from the National Archives, who will talk about the computer vision interface design and development. And then you'll also hear from Jack Craig from the V&A, who is one of 3 user researchers who worked iteratively with both the computer vision and the interface design teams in the research and testing of the technologies and concepts. We'll do questions at the very end of all 3 talks, but do feel free to enter them into the chat throughout the presentations. Joe Briggs will have to leave us earlier today, so if you have questions for her specifically, please do enter them as soon as you have them in your head in the chat. So without further ado, I will just introduce our first speaker. And as is customary, please just put your microphones on mute during the presentations. And at the end, when we do questions, you can unmute yourself. So our first speaker today is Dr. Dipu Manandhar, who is our postdoctoral research associate on the project. Dipu is based at the University of Surrey. He's working with John Colomas, as I mentioned. He obtained his PhD from Nanyang Technological University in Singapore, where his work was related to visual search. He's a postdoctoral researcher working at the Center for Vision. Oh my God, I'm gonna mess this up. Oh no, I'm sorry. Vision, speech, and something processing.
Signal processing.
Thank you. Yeah. I only have the abbreviation always, the CVSSC, there you go. At the University of Surrey, and he works with graphic UI design, layout modeling, and visual search tasks. I'm sorry again about that mess up there. Dipu, I'll hand over to you.
All right. Yeah, thanks, Laura, for introducing. I'll just start sharing my slide now. All right. Can you see my slides?
Yes, we can see it.
Yeah, thank you. All right, so yeah, I'm Dipu Manandhar. I work with Professor John Colomas. We are the computer vision and machine learning team in this project. So yeah, just let's get started with some. Yeah, so this framework is a basic diagram of how the system is working in our system. So there's a user front end which is trying to communicate with the search engine at the back end, and there's a web interface in here. So the actual workflow is like the user have some visual queries that's kind of image, for example this image over here, and he just want to search or retrieve similar image from the different collection. What he does is he supply this query to the web server, and web server communicates with our backend, and we extract some peculiar feature or image feature from this image using some machine learning algorithms. And these features are now getting mapped to the feature of collection over here. So we already compute this feature for all the images or all the collection in our database, and we kind of do matching in the feature space, and we get a visually similar image. So how these features are getting matched, simply like we can consider this particular image is matched to some high dimensional feature space, like n dimensional feature vector, into such kind of points over here. And let's say these are the close points, and this represents some visually similar images. These are the farther points. This kind of space is like green flowers, visually similar images, and those that are not similar, they are distant part. So like we compute some kind of distance and get the visually similar images. This is the basic workflow or framework of the visual search and deep discovery. So if you see this, what's this feature extraction or machine learning model, and how do we extract this feature from an image? And it's done with the convolutional neural network. Is a kind of neural network that came into hype after 2012. It existed prior to that from 1990s, but yeah, it came into hype after 2012. Basically, it's kind of deep neural network where you have different layers of network, and there is a convolution operator. That's why it's called convolutional neural network. And this image is passed through this convolution operation, some pooling and some MLP that's called fully connected layer. So this image is actually converted into some kind of n-dimensional feature vector where we compute the distance. So what actually this CNN is learning is, once trained, the earlier layers tend to learn some kind of edge features or blob features. And when you go in the middle layers, it try to learn some texture, mixing those edges and blobs. And as you go higher, you get some parts out of this texture. And when you mix this texture into when you mix these parts, and you get finally a complete image or sense of image. So this is how CNN works. It's a very basic description of CNN. Yeah. So finally, what the takeaway is, given an image, the CNN then convert this image into some kind of digital fingerprint, and that can be used for search. Yeah, and this is CNN. So our problem statement is like, we got different collection of images from different partners like TNA, VNA, RGBE, MODA, etc. And I think we have got collection of right now 17K images from these partners. Of course, we can increase this collection. So what kind of images we are working with? Yeah, it's kind of fabric, or some paintings, some wallpaper, some oil painting again, and mostly the images are coming from some floral or botanical themes. Of course, there are some images with such paintings as well. Yeah, so the problem is, we have a query image, for example, this one. We want to search whole database, try to find the similar ones we have, and try to discover like what we have in our mind. Well, I'll try to explain this in coming slides. All right, so what kind of model do we use? Of course, it's a CNN based model, but what does this CNN model is trained for? So we actually various models for example, like visual style based model. So this model is actually trained to discriminate like fine-grained visual styles, and actually trained on 1 million images of images. That's external data set, not from the collection. It's an external data set collected from Behance.net. And it's yeah, as I said, it's trained to discriminate the fine-grained visual styles. And we train like several models on this data set, like Aladdin S, Aladdin L, AVIT. All of these are actually coming from our group. All these models are actually coming from our group. One of them is in archive. The other one is still under review. The first one is also under review. Yeah, so the next one, semantic-based model. This model is trained on ImageNet dataset, basically using some softmax loss or contrast deep learning to actually categorize different types of objects in the image. Like specifically, it's trained to classify image into 1,000 different categories, like cat, dog, hen, likewise. So under this category, we also train like ResNet model, VGG16 model, VIT model. This VIT is a recently published transformer-based model. It's not an CNN architecture, but a transformer-based architecture. But the rest of the ResNet and VGG are convolutional neural networks. So we also propose to do kind of fusion, where we kind of hybridize any two of the model. So our feeling is like to combine the good part of two models, concatenate them, and explore good of the both models. So these are the summary of this model. Actually, we have like explored 7 different models, including the hybrid model or fusion model. So yes, this is the retrieval example for this query image. The query image is supplied for all this model, and these are the top 5 rank images retrieved from our database, and yeah, so you see like 6 different models, and they actually retrieve different images. The first one is actually repeated or duplicate image. That's in RGB collect, yeah, TNA collection. So it first retrieved the duplicate replicate image. That makes sense. And afterwards, the retrieval are different for different models. And now the question arises, like, why different model does retrieve different, different images in their top ranks. So it's because it's trained to do so. And can you explain it, or can we explain it? Yeah, so for this question, we try to explain why this, how this CNN is making decisions for this retrieval. Yeah, so what we explore technology called GradCam. Um, GradCam is used, basically used for producing some kind of visual explanation for CNN-based models. For example, here, so the let's say this is an image. We want to classify this, but the model says it's 60% of the cat and 35% of the dog, and like the rest of the person the hen or something like this. But why does it say 60% of cat and 35% of dog? So we can do some GradCam visualization. Let's say the target is dog, and we use this GradCam to create a heat map, like to show which area of the image it's concentrating on. uh, that makes the network think that this is a cat or it's a dog. So it's highlighted here, it's over the here, over here, and it makes sense, right? And because by human, they always like see the face of this, then distinguish, yeah, this is dog, yeah. So if you set the target as cat, the heat map is hovering around the cat region. So this is for the classification tasks, and we adopt this technology for visual similarity. So previously the target was labeled like, is it a cat or dog? Now the target is the image itself. So we are now at the visual similarity thing. So given this image, why this image is similar to this image? Because of this part, and not because of the blue part. So red is the higher response region, blue is the least one. And if you consider this, why this image is similar to this one, and it's because of this one, not because of cat. So yeah, we introduce, or we adopt this GradCam technology that explains why we are getting the retrievals on top rank, and what is getting matched on the hood. So yes, this is some example for heat maps on our model. So these are actually the second row is actually the retrieval. This is a query. This is first rank, second and third, fourth, fifth, and this one is query with rank image and heat map overlaid. Overlaid on top of it. So actually, it's like highlighted over the sunflower or flower regions here, like here a bit, and sometimes it just concentrate around this one. Maybe this is getting masked to this area. Yeah, so this is some example. This is a second example of heat maps trying to explain the visual retrieval. So next, we try to explore feedback or relevance feedback from user for visual search. So actually our main aim was to have some kind of visual discovery that can work for individual or personalized search. So maybe I have this image and I actually wanted to discover something else, but I don't have idea to describe in the keywords, or I don't know how to describe its attributes, but I have this image to begin the search with. And I supply this as a query. I get the retrieve image, and you see that all right, and on the top 5 image, I like this thing, and then this is what exactly I'm searching for. So what you do is, all right, so you select that image, you highlight that part. All right, give me something like more of this thing where I want this kind of pattern in my retrieval. This is what I'm looking for. So this is getting as a feedback into the system again. So we encode this thing from the thing annotated or indicated by the user using this feedback encoding thing. And this is incorporated into the search engine again. So this is kind of iterative search system. And now with this initial query and the feedback, we got the result that's actually intended by the user. So yeah, it's a refined result. So it's trying to disentangle the user intention. It's kind of also a personalized search. So different user will have this different taste, so it can adapt to that. So this is the second part of the work, to incorporate the user feedback for visual discovery. So how do we do this? Before going to the technology, I just wanted to briefly explain how what are the high-level vision models. So typically CNNs are global or holistic approach where you give the image as a whole to the network, and it just gives you some kind of vectors at the end. There is another model that was popular prior to deep learning or CNNs, that's called back of word model. So back of word model actually is like, this is an image of a person face, and it describes this image as a bag of different parts. So like nose, eyes, and this mix up together to form a face. So it's a kind of you have a dictionary of words, and then you pick different words to make a complete sentence. It's similar to like that. You have different parts of the image, you combine these things to make an object or an image. So yeah, in more details, for example here, if these are the collection of your part, like cycle, stance, something, yeah, these are called visual words, or we generate this using some kind of code book generation or k-means clustering, and these are considered as discrete words or visual words, and we construct a histogram on this visual words based on these parts. Like for example here, there's eye, different parts, and then we constitute a histogram for this. So eyes and skin area are higher rank. I mean, they get higher beans, and whereas this thing get like higher. So it means that for different images, you get different kind of histograms, and you compare this histogram to get the image similarity. Yeah. So how do we implement this thing or this idea into our search system? So we basically take our images, patchify them, like divide this into several patches, like 5x5 patches, like 25 patches, 5 by horizontal, 5 by, we patchify them, we get the patches, and we actually apply CNN on this patch, not on the whole image, and we get some features for each of this patch. Now we extract all of these patches from our training set, and we project this into some space. And then we do some kind of vector quantization. It's we use k-means clustering algorithm to do that. Once we do that, we got a code book of visual words. So it's we can now define any new image in terms of histogram of this code book or histogram of this visual words. So now, as I said, this image is like can be represented as this histogram, but this image, we patchify it, different patches, this model, and you get different histogram. Now we compute, the distance between these two histogram, and we get the retrieval results. It's already implemented in our web demo that's going to happen afterwards. yeah, I have a video as well. So basically I'm trying to explain how this system is working. So in more detail, like this is the query image, these are the retrieve image. Now you want to explain why these two are getting retrieved. It's because this patch actually getting matched to those patches. You see, these flower bits are matching with the other flower bits. So it's already kind of makes sense, right? So the actual flower bits are matching with the flower parts all over the image. So that's why it's getting on the top rank image for this query. And likewise, this is a second example. Yeah, so different color represent different kinds of patches, different visual feature based patches. Oh, all right. So this is a quick demo. I'm trying to, maybe this might be repeated later and again, but I'm trying to show this demo in terms of the computer vision technology. Yeah, so display. This is the demo for deep discovery visual search. To start a search, just click on one of the example image on the screen, and it just starts searching the. So these are the top retrieve images available in our dataset, and you can also see the heat maps by clicking on the like image view. So now for the user feedback, let's say you're interested in this white flower. So you just click on this image, go to the top menu, you see the image you've selected, click on edit search. So you're actually interested in the white part or white flower. So you have a brush light tool over here. Just highlight this part and update selection. So now once you go back to your main page, the system will try to incorporate the white flower into the search, and we expect white flowers on top retrieval results. And there you are, white flower, yeah, some pink flower or purple flower, similar to the white one, this color as well. Yeah, so this quick demo from computer vision perspective. I guess you will have a live demo by Bernard after this. Sorry. Yeah, so although the project has been almost come to an pharma end, but we are still doing continuing this work to to like basically we use the back and forth model for the previous demo. Now we want to have some kind of novel neural network to do this. So basically this is a query maze, there's a feature extraction, this is a basic pipeline, but what we want to do is to have, like, if the user have this query or feedback thing, there's a new neural network that takes this feedback into account, and this conditions this feature vector and project the whole feature space into the new space, search space, where we consider both of these two. So we are heading toward this idea, and I'm actually working on this together with John. Yeah, this ongoing work. Yeah, so yeah, so we have developed like visual search system for deep discovery and searching different collections. We try to explain the search results, like why the CNNs or the machine learning model is retrieving those images with GradCam technology and heat maps. And we further realized that like there should be some personalized search where different users have different tests, and so we incorporate the user feedback and iterative search, and we already have a web demo about that. And yeah, so that's all from us. We Dipu, Manandhar, and John Colomos. Hope you have some questions at the end. Yeah, thank you.
Thanks, Dipu. So you've seen a very interesting development in terms of computer vision explainability and the ability for a dialogue to kind of develop between the user seeing what the computer vision algorithm is finding similar in the images, and that being actually shown to the user so that they can actually then refine their search based on their specific task. And we'll learn more about kind of the interface and how this was conveyed to users, as well as why we decided to go down this particular research route from our next speakers.